continuation of elements of grid computing. What are the grid computing essence we have to see now, and later we have see the elements. Okay, the essence in the sense what is the important of grid computing, it can be captured in a simple checklist. Okay, according to which a grid is a system is that. Okay, it coordinates resources that are not subject to centralized control. Okay, this is the essence of grid computing. And we have to say the one more point, it using standard and open general purpose protocols and interface, and one more to deliver non-trivial qualities of service. Okay, a grid allows its constant resources to be used in a coordinated fashion to deliver various qualities of services. Okay, various qualities of services the grid want to deliver. Okay, and what the grid vision requires standard protocols here in the sense interfaces and policies that are not only but that are not only purpose of the interfaces and policies but also general purpose. These protocols allows us to establish resource sharing. What sharing? Resource sharing the element arrangements dynamically with any interested party, and to create compatible and interoperable distributed systems. Here what exactly the elements of grid computing in the sense, here elements of grid computing combines elements such as distributed computing and high performance computing and disposable computing, it depending on the applications of the technology. Okay, and the scale of operation, what operation it will be performed. And grids can create a virtual supercomputer out of the existing servers. Okay, and workstations and personal computers. Present day grids encompasses the following types. Okay, here we learn here resource sharing in the sense computers, data and storage, sensor networks, and sharing always conditional issues of trust, policy and negotiation, payments. Okay, it coordinated the problem solving, it beyond the client server, it distributed the data analysis, how it will be computation and how it will be collaboration, etc. and so on. It will be dynamic and multi-institutional virtual organization. What is the meaning of the a virtual organization? In the sense nothing it is a temporary or a permanent collection of geographically dispersed individuals, in the sense group of groups, the sense organizational units or entire organizations that depend on electronic linking in order to complete the production process. Okay, it's nothing but some groups, some organizational units, entire organization that depends on electronic linking. Okay, it's nothing but virtual organizations. It's community overlays on classic organization structures, and large or small and static or dynamic. It can be changed, it can't be changed. Okay, here we have some following types. Present day the grid follows. Okay, first one, here the grid topologies, in the sense these are present day grids encompasses the following types. In the sense grid topologies, grid is a network. Okay, it's a distributed computing infrastructure. Whatever the client needs, it should be able to provide to access. Topologies, in the sense it's a structure of a network. We have some computational grids, scavenging grids, data grids, market oriented grids, resource management and security management and data management and services management. These are included present days grids encompasses these are the following types. Here we have to learn important intra grid. In this intra, the names itself says what it exactly, local grid within an organization, and it trust based on personal contract. contracts. In the sense, the definition of standard intergrid, in the sense it is the single most critical problems it's facing the grid community today. Global Grid Forum is a consortium working in the direction for implementation purpose. Globus toolkit and open source middleware is being widely used as that platform. Okay, coming to the extra grid. Extra, the name itself says what it, resources of a consortium of organizations connected through a private network, in the sense virtual network. Here, trust based on business to business contracts. And coming to the intergrid, in the sense global sharing of resources through the internet. And one more point, trust based on certification. Okay, here we have to learn what is a computational grid. Okay, first one, what is a computational grid? In the sense, in which missions will set aside resources to number crunch, in the sense data or provide coverage or other intensive workloads. In the sense data intensive workloads, it is referred to as big data. It's a parallel and distributed computing. Okay, a computational grid is a both hardware and software infrastructure that provides a dependable and consistent and spreading throughout the area, and spreading widely throughout an internet and inexpensive access to high-end computational capabilities. For example, science grid, in the sense US Department of Energy. Okay, and coming to the data grid, what is the concept of data grid? Look at this, all of you. Data grid, in the sense which provides a unified interface for all data repositories in an organization, and through which data can be queried, managed and secured. In the sense, it is a grid computing system that deals with data, the controlled sharing and management of large amounts of distributed data. Okay, data grid is nothing more, it is the storage component of a grid environment. It is scientific and engineering applications. It requires access to large amounts of data, and it often this data is widely distributed, and a data grid provides access to local or remote data. It required to complete the compute intensive calculations. Okay, for example, biomedical informatics research network and the Southern California earthquake centers, these are the examples of data grid. We have seen here present day the grid encompass one more type, scavenging grid. Scavenging grid, in the sense it commonly used to find and harvest mission cycles from idle servers and desktop computers for use in resource intensive tasks. Here, scavenging, scavenging, in the scavenging, in the sense it's usually implemented in a way that is unobstructive to the owner or user of the processor. Okay, this is the scavenging grid. Okay, here we have to learn about the methods of grid computing. What are the methods we have to learn in grid computing? The first one is distributed supercomputing. Already we learned in the first topic, distributed computing. We have to know multiple autonomous computers connected through a internet. Okay, connected via internet. Okay, we have to accessing and processing and sharing data, software and system to other systems. High throughput computing. Okay, the high throughput, in the sense the items passing through a system. Okay, what we have to manage to process, to develop, both include software and hardware development equipments. Okay, on demand computing. On demand computing, in the sense it's nothing but cloud to deliver and accessing, processing, managing applications via internet. Coming to the data intensive computing, in the sense it is a it is a parallel and distributed networks. Okay, and coming this one more, which used to a data parallel approach to process large volume of data typically terabytes and petabytes in size, and it is typically referred to as a big data. And coming to what we have to collaborate to manage process the things whatever you need, that is we want to collaborating the computing and logistical networking also we have to follow here, the one of the method of grid computing, logistical networking. And coming to the one more topic here, grid standards. Here the table shows you grid standards and toolkits for scientific and engineering applications. Here coming to the, we have to see what is a middleware. A collection of software is being a middleware. Okay, here we have to learn the grid standards, OGSA standard, open grid service architecture standard. The major grid service functionality in the sense it offers common grid service standards for general public use. What the key feature and security infrastructure in the sense it support heterogeneous in the sense different distributed environment, bridging CA and multiple trusted intermediaries, dynamic policies and multiple security mechanisms, etc. We have etc. Okay, and the next one, the one more grid standard we have Globus toolkit. Globus toolkit on, okay, Globus toolkit is a open source middleware. It is being widely used as the platform, okay, a resource allocation, global security infrastructure and generic security service application programming interface. This is the major grid service functionality. And coming to the key features and security infrastructure of global toolkit in the sense sign in multi-site authentication, and authentication with public key infrastructure, Kerberos, SSL proxy, delegations and application programming interface for message integrity and confidentiality. And coming to the one more grid standard we have IBM grid toolbox. Okay, the major grid service functionality here, it's a Linux grids. It's built on top of Globus toolkit, autonomic computing and replica services. It doesn't dependent. The word autonomous in the sense independent computing, and it replica services also it will be provided. And what is the key feature and security infrastructure of IBM Grid Toolbox in the sense using simple CA and granting access the grid services, supporting grid applications for Java and grid map in intra-grid for security update. Okay, this is the this is the grid standard and middleware for specific scientific and engineering applications. Okay, and coming to the, this is the typical view of grid environment. Okay, this is the user, this is a resource broker, this is the grid information service, this is the grid resources. Okay, these are the few typical view what the user typically view of a grid environment. Here what is a grid information service in the sense, a grid information service, it is a system collects the details of the available grid resources and passes the information of the resource broker. Okay, at the passes of the resource broker, what does the purpose of resource broker, it distributes the jobs in an application to the grid and resources based on users quality of service requirements and details of available grid resources for further executions. Okay, and coming to the grid resources, what the grid resources purpose, clusters and PCs, personal computers and supercomputers and database instruments, etc. in the Globus grid executes the user jobs. This is the purpose of grid services. This is the overview of grid environment. Here grids are typically managed by gridware. Okay, a special type of middleware that enable sharing and manage grid components based on user requirements and resource attributes, for example capacity, performance. Okay, the software that connects other software components or applications to provide the following functions. What are the functions we have to see now? Run applications on suitable available resources, like brokering, scheduling. Okay, and coming to the one more point, it supplied uniform and high level access to resources and semantic interfaces, like web services, service oriented architectures. Okay, and coming one more point, address inter domain issues of security and policy, etc. We have to monitoring and we have to control it. Okay, later in further topic we have to explain the overview of grid architecture later. Thank you.